Hi, G. We're just going to ask you a few technical questions now as part of this. So, firstly, if a head gasket is damaged, what colour exhaust smoke could there be emitted from the tailpipe?
Okay, so head gasket can actually cause a few. A lot of people think it's just one, but it can actually be a few. So it can be black, but it can be blue, but it can also be white, or it can be a combination of that. The reason for that is because when the head gasket goes, for example, if the compression is gone, it's on a diesel, and so the compression isn't there, so that cylinder itself is not firing properly, which means if there's unburnt fuel, you could get black smoke because it's lack of compression on that. If, for example, the head gasket is leaking between the galleries and the water jacket and oil is now going into the cylinder, it could be burning oil, so then it could be blue. If, for example, the coolant is now going into the cylinder, either because where between the water jacket and, as I said, is now the other way around, and coolant is going into the cylinder and it's burning coolant, you could get white smoke. So it could be a combination of stuff, but you'd have to do more tests to determine which element of it is gone. But more than likely, head gasket would have to be done.
Explain the term volumetric efficiency for me, please.
Sure. So engines with forced induction, so for example, superchargers and turbochargers, what you're working out is how efficient does the cylinder draw or bring air in or have air put into the cylinder, and also extraction, as in on the exhaust side. So a vehicle that does not have forced induction, meaning it doesn't have a supercharger or turbocharger, which is known as a naturally aspirated engine, it's usually around 80% efficient. And the reason for that, or 80 to 85, is because the time that the valve is open, the inlet valve is open, as the air is being drawn in, because it's trying to balance out between atmospheric pressure and cylinder pressure, it's hitting things. It's hitting, for example, the air filter, it's hitting the manifold, it's hitting the valves, and then by the time the valves close, the amount of air that's in there, which is balanced out, is around 80%. When you then now switch it to forced induction, okay, even though the other elements are there, because it's now being driven, and what you're now doing with air, you can compress air. So what happens is while the inlet valve is open, the air from the turbo is being forced into that. So as you can compress that air, it just keeps on filling, and in that same time period, you can now make that engine around 120% efficient for volumetric efficiency.
And what is the purpose of the differential within the final drive unit?
Okay, so lots of times there are confusions because when we talk about that, we just talk about the rear axle and it's all one unit, but there are two different things. So the differential, sorry, was the differential you asked for?
Differential, please,
Absolutely.
yes.
So the differential actually only comes into place when a vehicle is going around the corner. So the purpose of the differential is to allow the wheels to turn at different speeds when going around a corner.
Thank you. And can you tell me the components that we mentioned that, part of the final drive? Could you just tell me the components that make up the final drive, please?
Sure. So as I mentioned, rear axle, so I will separate it. So the actual final drive only consists of two main components, which is the crown and the pinion, which creates the final drive. However, onto the crown wheel is also bolted the elements of the differential. So those elements are, there's two side gears or sun gears, and you've got just planet gears. And how you know which ones are the side or sun gears are the ones that are splined, where usually the half shafts will be splined into that.
And in relation to chassis, what controls the ride height of the bus?
So there's actually, it's controlled by air, but it can actually be done by air electronically. So there's two ways. We have what's known as the leveling valve. So on older vehicles, it's standard what we call a mechanical leveling valve. And how that operates is you've got the air system that will give the air that is required for the suspension. But to control the actual ride height, we've got components like the airbag, the pedestal, the top plate, and what controls air going into it is the leveling valve. The leveling valve is like a control system that has a leveling rod, which is then connected to the chassis or to the axle. Then that rod is connected to a leveling arm. So the rod, as it moves up and down, will levitate or make the arm move up and down. As it moves through a certain amount of degrees, it will then control the amount of air going in or out of the airbag. Because the rod is being preset to a ride height, so what would happen is it'll always try to go back to that preset ride height. So when a bus basically hits a bump, the arm is moving, but it's trying to reset to where that rod is.
And could you just explain to me the term caster, please, and what that is in
Sure.
relation to steering angles?
So vehicles have different types of steering angles, and it's about how you define it and how do you look at it. So when it comes to caster angle, the first of all, what you need to do is the way it's viewed is from the side of the vehicle. So if you were to look at, if you sort of like think that's the side of the wheel, that's the tire. And on light vehicle, okay, you can use the McPherson strut as a way of knowing if it's positive or negative. So if the McPherson strut is more towards the back of the vehicle, it's known as positive, and if it's towards the front of the vehicle, it's known as negative. The purpose of caster actually helps with two elements. Number one, it's about the feel of the steering wheel, because if you have, for example, positive caster, what it can do is actually make it feel, if I'm just getting this right, if it's towards the back, lighter steering, and if it's towards the front, if it's negative, heavier. So depending what the requirements of that vehicle are. The other key element, okay, is what we call the returnability, or center point steering, as in self-centering action, sorry. So what that means, example, when a vehicle goes around a roundabout, we shouldn't do this, but when you let go of the steering wheel, the reason that the wheel will try to return back to center is because of the caster angle, because what caster allows it to do is when the angle is there and the vehicle is moving forward, it will try to self-center.
I'm going to move on to the electrical subject now. And could you just tell me how many cells are there in a battery, a typical battery?
Okay, so obviously I'm used to bus, but I know in cars as well. So even though in buses there's two batteries, that's two separate ones, but each battery is 12 volts. So just like a car is 12 volts, okay, a bus is two 12 volts. So if I take one battery as I know it, in there are 6 cells. And approximately in those cells, you think it'd be 2 volts, but it's actually slightly above. If it's a good battery and it's holding good charge, then it could basically hold anything up to 2.1 to 2.2 maybe, which would make it above 12 volts. But if you really test the battery, you know, a good battery usually around 12.6 or 12.8 volts.
And what would be the correct procedure if you was disconnecting the batteries?
Absolutely. So we've been taught that obviously because it's a circuit, we need to break that circuit safely because it's when it's all connected up. So first of all, make sure that you've got the right equipment to work on. You're wearing the right PPE. Make sure that if you isolate, there's an isolation switch. Turn that off. And then once you get to the battery, what you should be doing is you start with what we call the negative. Some people call it the earth, when we talk about the negative terminal first. On our buses, as I said, what you've got is a negative, then we've got what's called a bridge cable, and then we have the positive. So how we do it, isolate it, disconnect the negative first. Some people will go for the positive and then the bridge, but I prefer to do negative. Then I would take off the bridge, then take off the positive. And then when I'm refitting it, once again, make sure it's in good condition, then I would do positive, bridge, and then negative.
Excellent. And in relation to an alternator, what's the purpose of the rectifier?
So the alternator itself, because it's a sort of what I would call a mechanical electrical component. So it's mechanically driven by a belt. And what that does, because as it's inside the rotor is spinning, what it does, it creates a fluctuation of AC or alternating current voltage. And what the batteries need is DC. So what you need to do is change it from AC to DC. But what you also need to do is level it out, because what you don't want is a high amount of fluctuation in the voltage.